Good afternoon, students. In the last class, we discussed about preparation of H2SO4 from contact process, its flow chart, and its chemical properties and physical properties. So, in today's class, we are going to study with that is 17 group elements called as allergens. Okay, so these 17 group elements are called as allergens. Why means this allo means salt, gel means synthesis. So these 17 group elements, when they combine with other elements, they form salts like NaCl, NaF, HF, HCl, KCl, okay, MgCl2, MgBr2, like that. So if they combine with any metals, they form salts. So salt forming elements, that's why they are called as halogens. So students, in the halogens, the elements present are fluorine, chlorine, bromine, iodine, acetylene. Okay, so here atomic number, electronic configuration, this is right here general, later I'll write. So listen, first I'll consider periodic properties. In this periodic properties, first one is electronic configuration. Okay, so in this electronic configuration, general electronic configuration is Ns2 Np5. That means here chlorine is there, it is helium 2s2 2p5. This chlorine, that is neon 3s2 3p5. Next, this bromine argon 4s2 4p5. This iodine krypton 5s2 5p5. This one is xenon 6s2 6p5. So the last valence electron is what? This ns2 np5. That is the first periodic property. Okay. So next one is students, that is atomic size. Atomic size. Okay. This atomic size, as it is 2, 3, 4, 5, 6 means along the group, that is increases from fluorine to acetylene. Increases from fluorine to acetylene. Next, ionization energy. Ionization energy. So students, here ionization energy, as the size increases, energy decreases. That means decreases from fluorine to acetylene. Next, electronegativity. Electronegativity. Here this is also decreases from fluorine to acetylene. Okay. Next, electron gain enthalpy. So this is somewhat changes friends. How? Listen, this is also decrease electron gain enthalpy. Decreases from fluorine to chlorine. But listen, instead of this, it is follows the order chlorine, fluorine, that is greater than. Next, bromine, next iodine. Understand? So instead of fluorine, chlorine has high electron gain enthalpy. Reason, fluorine is smaller in size. Smaller in size means there is a great repulsion. Electron gain enthalpy, addition of energy released when an electron is added to the atom. So here always the trend follows from chlorine to acetylene, chlorine to acetylene. But here chlorine greater than fluorine, greater than bromine and iodine. Understand? This is very important. Always they'll ask this for one part, which is the which one has the high electron gain enthalpy? Which halogen has high electron gain enthalpy? That is chlorine. In our mind, we think, of course, it decreases from top to bottom means chlorine is highly electron gain enthalpy element. But that is wrong. If it is like that, they won't ask. Okay? So they'll ask which of the following halogen have high electron gain enthalpy? That is chlorine. Reason, because of smaller size of this fluorine. Understand? Next, here the periodic properties. If we consider physical properties, in this physical properties, these two are gases. This one is liquid, and this one is solid, and this one is radioactive. Gases, liquid, solid, and radioactive. So students, this one is yellow in color. This is greenish yellow. This is brown. And this one is violet. So this don't have any color. Okay? Yellow, greenish yellow, brown, white. Understand? So students, if we think solubility, these two are soluble in water. Okay? And these two are partially soluble in water. Partially soluble in water. Okay? And completely soluble in inorganic solvent. Completely soluble in, if you want to check, okay, organic solvents. Organic solvents. Organic solvents means it may be ether, it may be benzene, okay, acetic acid, like that. Organic solvent. Inorganic solvent means HCl, H2SO4, water, ammonia, like that. So these are the physical properties. Understand? If we consider boiling point, students, listen. These two are gases. This is a liquid. This is a solid. Solid has high boiling point because it should convert into liquid first. Later, it boils and convert into gas. So these are gases means they have less boiling point. So along the group, the boiling point and the melting point increases. Understand? So on all halogen atoms present here are non-metals. All the elements present in these halogens are what? Non-metals. Okay? So this is another physical property. Next, if we comes to chemical property. Okay? If we comes to chemical property. General property I am telling. Okay? So students, the first one is reactivity or reaction with hydrogen. For example, any halogens that is X2, when they treated with H2, they form two HX type compounds. Right? X2, H2 gives rise to two H's. X is what? Halogens. That is chlorine, bromine, iodine, not astatine. Astatine is a radioactive element. Okay? So here the order is HF, HBr, HCl, HBr, HF. So students, which one is strong acid, which one is weak acid, we have to check. Listen, what is acid means? One which easily donate H plus ion. One which easily donate H plus ion. Listen, fluorine is having less size, correct? So listen, HF size is this much, HCl size is this much, HBr size is this much, and HI size is this much. Okay, so that means as size of fluorine, chlorine, bromine, iodine increases, the bond length increases. Correct? That means there is, these two are very far away from each other compared to this and this and this. From here, which bond requires less energy means this bond. Because the bonds, they are far away from each other, they are this much distance there. Okay, if they are too much distance, so then we require less energy to break the bond. If HF bond is only this much, they are very close to each other, then the force of attraction is more, then we require more energy to break the bond. If bond cannot be break easily, then they won't form H plus ions. The one which gives H plus ion doesn't give H plus ion, that is a weak acid. Okay, that means among HF, HCl, HBr and HI, which one is the strong acid? Means HI is strong acid. Correct? Like this. Reason, because the bond distance between HI due to the larger size is more. So if the bond length is more, bond energy we require is less. Okay, if we require less energy to break the bond, it easily donate H plus ion. Hence, Hi is the strong acid. So this is what? This order is acidic nature. Okay, stability if we come. So listen, HF, HCl, HBr, HI. Okay, which one is more stable here? This. As I told you, size is very less. So this is the stability order. Remember, don't confuse in this. Which one is? So this is more stable. That's why it won't give H plus ion. That's why it is less acidic. So this one is less stable. So it easily dissociates H plus ion. That's why it is highly acidic. These trends are important for 1 mark. Always there in class. So students, this 17th group elements is very important among all the groups of the people. From 13 to 18, this 17th group element, their reactions, their variation, their property is very important. Understand? So the next one is students, its reactivity towards oxygen. Listen. Second one, chemical property, then oxidation state. Listen here. Here 2s 2p is there. After 2s 2p, the next orbital is 3s. 3s 3p means next is 3d. 4s 4p means 4d. 5s 5p means 5d. 6s 6p means 6d. Correct? So here, except fluorine, each and every atom has d orbital. Are you getting? So, except fluorine, after 2s 2p, 3s will come. There is no d orbital. But from chlorine, bromine, iodine, acetylene, the next orbital is the d orbital. Understand? So that's why, due to the absence of this, the oxidation state of fluorine, these elements exhibit which type of oxidation state means -1, +1, +3, +5, +7. This type of oxidation states can exhibit -1, +1, +3, +5, +7. Okay? How? Listen, I will take this 3s, 3p, 3d. Correct? NS2, NP5. This is the one. So students, listen. They can accept one electron to attain noble gas configuration. That means this is -1 oxidation state. Okay? It can lose one electron. That is -1. It can lose 3 electrons. That is +3. It can lose these electrons also. Sorry. It can lose 3 electrons. So +3. Okay? And can lose all the 4 electrons. It cannot Again plus 5, it is plus 7. Understand? These are the oxidation states exhibited by plus 5 is also there. Plus 5 and plus 7. Understand, students? So these are the, here I take, listen, if I increase that, then you can understand. 1, 2, 3, 4. From this, we can show plus 1 as well as minus 1 oxidation state. If we increase this here, then plus 3 oxidation state. If we increase this here, 1, 2, 3, 4, 5, plus 5 oxidation state. If we excite the molecule here, 1, 2, 3, 4, 5, 6, 7, that is plus 7 oxidation state. Are you getting? They may have the capacity to exhibit up to 7 oxidation. Plus 7, plus 3, plus 5, plus 3, plus 1 as well as minus 1. Okay, so in that, which one can exhibit only minus 1, which can exhibit the positive states, means that is explained by this electronic configuration. Listen, here fluorine is there, it won't have any d orbital. ಇಲ್ಲಿ ನಾನು d orbital ನ ಬರ್ದಕಲ್ತಾನೆ ಅದು excitation state ಅಲ್ಲಿ ಹೋಗಿದ್ದು. ಅಂದ್ರೆ next orbital d orbital ಇದ್ರೆ ಮಾತ್ರ electrons jump ಆಗುತ್ತೆ d orbital ಗೆ, ಅವಾಗ ಮಾತ್ರ positive oxidation state ಬರುತ್ತೆ. ಇಲ್ಲಿ fluorine ಅಲ್ಲಿ d orbital ಇಲ್ಲ. So fluorine exhibits only minus 1 oxidation state. Fluorine ಯಾವಾಗಲೂ minus 1 oxidation state ನ ಮಾತ್ರ exhibit ಮಾಡುತ್ತೆ. Understand? And next, remaining exhibit minus 1, plus 1, plus 3, plus 5, plus 7 oxidation state. Okay, next. So students, next one is reaction with oxygen. Third one, reaction with oxygen. Listen students, initially by explaining this entity, boron, carbon, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, etc. Okay, this much is enough. Listen, along the period, electronegativity increases. Along the group, electronegativity decreases. Correct? So among oxygen, fluorine and all these elements, this fluorine is greater electronegativity than oxygen. Oxygen has greater electronegativity than fluorine, than bromine, than iodine. This is the trend. Are you getting? Fluorine is highly electronegative than oxygen because it is this oxygen present in 16th group. This is present in 17th group. And along the group it decreases, means of course the oxygen is highly electronegative than fluorine, bromine and iodine. This is the trend. Okay, so that means why I wrote this? Listen. So if oxygen is there, if it reacts with fluorine, oxygen is there, if it reacts with fluorine, so this is oxygen having minus 2 oxidation state, or it can has plus 4 oxidation, plus 2 also, plus 2, minus 2, plus 4, you know that. Okay, so students, here it can exhibit plus 2 oxidation state, means as fluorine is highly electronegative, means this will get minus, this will get plus charge. That means they form the compounds like OF2 and also O2 combines with F2 form O2 F2. Two types of products they will form. This one is 2 type. As this is a highly electronegative atom, this compounds will form like this O2 F2. Next, compare this. If any chlorine except this, consider X. X may be chlorine, bromine, iodine, except fluorine. X means these three. Among these three, oxygen is highly electronegative. So if X reacts Students, here they cannot be X, they must be X2 because they are allergens. Understand? Then plus 1 plus 3 plus 5 plus 7. Listen students here, X are in plus 7 oxidation state, that means halogens, and this is in minus oxidation state because compared to this chlorine, bromine, iodine, oxygen is highly electronegative. Understand? Here compare here, fluorine, it is highly electronegative than oxygen. That's why oxygen is in plus oxidation state, fluorine is in minus oxidation state. This is the difference. Anomalous behavior, different behavior of fluorine. Understand? So this is all about their electronic configuration, their physical properties, periodic properties, and chemical properties. Okay, so next we will discuss with the important compounds of allergens in the chlorine Cl2. So next one students, preparation of Cl2. Important compound that is Cl2. So how the preparation of Cl2 takes place? So first one students, by the action of KMnO4 salt is there, when it is treated with HCl solution or HCl acid, then they form MnCl2 plus KCl plus H2O. Okay, plus Cl2 we want. Major product we want is what? Cl2 only. Okay, so that is we take 2 KMnO4, so 2 MnCl2 and 2 KCl, and remaining is this is 60, since it is 8H2 and this Cl is how many times? 16 means 8, so not 8, it is 4 by 6 means 5 Cl2. This is the balance reactor. First, by the action of HCl on KMnO4 salt, potassium permanganate salt gives chlorine, NaCl2, KCl and 8H2. One type of preparation. What you are studying? Preparation of Cl2. It is a laboratory method. Understand? So the next one is when NaCl is treated with water. NaCl is treated with water, undergoes electrolysis. Electrolysis means here NaCl solution is there, 2 electrodes will be there. And this is aqueous solution, Na plus ion and Cl minus ions will be there. So this Cl is precipitated at anode. This one is cathode. Anode means where the Cl minus ion, negative ions attached. This is Cl minus, Cl minus, Cl minus. They accept, they loses an electron. 2 Cl minus loses an electron, become Cl2. Understand? This is what electrolysis process. Electro means electrodes. Lysis, electrode you may think or electron you may think. Lysis means separate or break. Okay, so breaking of this NaCl molecule with the help of current, that is called as electrolysis. Understand? So here this is done by this method. So here it will form NaOH plus H2 plus Cl2. So students here 1, 2 NaCl. Here it is 2 NaOH. It is H2. Understand? This is the second type of preparation. Industrial preparation with electrolysis. This is preparation. This is industrial preparation. So third one is when manganese dioxide is heated in presence of HCl. Is heated in presence of HCl. No doubt here, this one is taken in 4 moles means. 4 moles. First you write this is MnCl2 form. Okay. Next Cl2 will form. Next H2O will form. Cl2 here 4 times is there. That is 4. And here it is 2. Yes, it is balanced. MnCl2 plus Cl2 plus 2H2. This is another one preparation method. So the next students important process of preparation of that chlorine, that is called as Deacons process. Deacons process. How it is prepared? By treating this HCl in presence of atmospheric air. This is atmospheric air. HCl is treated with or reacted with atmospheric air in presence of CuCl2 as a catalyst. Okay, HCl is treated with atmospheric air or made to react with atmospheric air in presence of CuCl2 as a catalyst, then it forms Cl2 and H2. So students, 2 moles of Cl2 and 2H2 is there, 4 moles, and this one is 2 mole, this one is 2. It is balanced. So these are the preparation methods for the preparation of what? Cl2. So this is what? Deacons process, important. Understand students? So this is all about what? Preparation method. Next we will discuss physical property. So students, it is a colorless gas. A colorless, not colorless, white. It is colorless only, but it seems like white. It is a colorless gas. Okay. Next, it is soluble in water. It is soluble in water, highly reactive, Okay, so these are the physical properties. Next, we will study chemical properties. Very important. That is chemical properties. So students, I start chemical properties from here only because I need much space. Chemical properties. Okay. So in that first one is reaction with ammonia. Okay, this is a very important reaction. Why? Because always the most asking question. Reaction of chlorine with ammonia. How? So listen, if chlorine is there, if it reacts with excess of ammonia, this is excess. If chlorine reacts with excess of ammonia, form NH4Cl plus N2. NH4Cl plus N2. So this one is in 8 mole, this one is in 3 moles. We get 6 NH4Cl. Okay. Next, listen students. If this same ammonia reacts with excess of chlorine, form N2Cl3, NCl3, NCl3 plus 3HCl. Are you getting the difference? If ammonia is excess, chlorine is smaller amount. If the chlorine reacts with excess of ammonia, result is NH4Cl. If ammonia reacts with excess of Cl, then NCl3 is common. This type of comparative reactions are very important for 1 marks, as I told you. Okay, next, second one is reaction with metals. Reaction with metals. For example, sodium is there. If it reacts with Cl2, form 2NaCl, because this is the reaction. Next, magnesium is there. If it reacts with Cl2, form MgCl2. Okay, next. Okay. This aluminium is there. If it reacts with Cl2, form AlCl3. So this is 3 moles, this is 2 moles, this is 2 AlCl3. Okay, next. This is what? Reaction with metals. Third one is reaction with non-metals. Reaction with non-metals. So listen, if phosphorus is there, if it is treated with chlorine, forms phosphorus trichloride. Okay, same phosphorus is there. If it reacts with 5 moles of Cl2, form PCl5. Then sulfur is there, S8. When it reacts with Cl2, form S2Cl2. Form S2Cl2. So this is 4 moles. This one is 4 moles. This is what? Reaction with non-metals. Understand? So the next one is oxidation property. Oxidizing nature. Oxidizing nature. So students, what are oxidizing? The species one which have the capacity to accept an electron. You know, they are always in negative state, negative oxidation state. Why? Because they have electron to attain a noble gas configuration. So they always prefers gain of electron. Gain of electron means that is reduction. Understand? One which undergoes reduction that oxidizes other elements. So that's why these allergens, by accepting an electron, oxidizes other elements. The examples that shows oxidizing nature is when FeSO4 salt is treated with allergen, that is chlorine especially, in presence of acid, forms okay, forms Fe2 SO4 rise in presence of H2SO4 again. This is 2 moles. This is 3 moles. This is 3 moles. Plus 6 HCl. Understand? So this is the answer. 2 FeSO4 plus 3 Cl plus 2 H2SO4 gives us to Fe2SO4 rise plus 6 HCl. Understand? Okay. Here Fe is in plus 2 oxidation state. Here it is plus 3 oxidation state. So loss of electron means that is oxidation. This chlorine, here it is in 0 oxidation state, here it is in -1 oxidation state. So by accepting an extra electron, it oxidizes this iron from +2 to +3. Okay, so the next one is SO2 when it reacts with Cl2 in presence of H2O. SO2 reacts with Cl2 in presence of H2O forms H2SO4. So students here, SO2 is there, H2O is there, 4 moles means we require 2 H2O. So to support, here Cl is there, that is 2 Cl. Here sulfur is in +4 oxidation state, here it is in +6 oxidation state. +4 and +6 oxidation states. Loss of 2 electron takes place. These two reactions tells about oxidizing nature of chlorine. Not only chlorine, anything. Understand? So if another one is the last one, very important, that is bleaching action of chlorine. So students, in bleaching powder, we use chlorine as the main content. Understand? How the bleaching action takes place, you know, the composition of bleaching powder is CaO, Cl twice into CaCl2 into CaOH twice into H2O. This is the composition to H2O. Composition of bleaching powder. CaOCl2, CaCl2, CaOH twice into 2H2O. So students here, upon oxidation, this gives Cl2 gas. So listen, when this Cl2 liberated here is treated with H2O means it forms 2HCl with nascent oxygen. 2HCl are it formed initially 1 HCl and 1 HOCl. So this HOCl again decomposes, then they form HCl and nascent oxygen. Directly they form 2 HCl and also 1 nascent oxygen. So students, this nascent oxygen reacts with or come in contact with the colored compound. You know, fabrics are in color. What I wear is brown color. Okay, this is any fabrics. Fabrics are, of course, they are in color. So how this bleaching action works means When this CaO, Cl2 and CaCl2, CaOH2 and CH2O, when they come in contact with water, they release chlorine gas. So this gas react with water molecule from HCl and HOCl, hypochlorous acid. This HOCl again decomposes, gives HCl and nascent oxygen. Nascent means single oxygen. This single oxygen is the reason for bleaching action because it is colorless. When colored fabrics is come in contact with this oxygen, it forms them colorless. Understand? So this is all about the chemical properties. So listen students, what I wrote here are very important because as I told you, not only one mark, how many marks in us? So complete this chlorine, allergen, 17 group elements, their reaction is very important. Leave anything from this chapter, you may leave 16, 7, 15 group, 16 group, but you can't leave this. At least one question from this always going to ask in each and every examination. Very important. Among those, this one is highly very important. Okay, most of the time, often asking question this is. What is the product when chlorine reacts with excess of ammonia? What is the product formed when ammonia reacts with excess of chlorine? So this type of reactions are very important. Understand? Okay. So in the next class, we will discuss about the preparation of HCl and its chemical property and its physical property. Okay.